we need a coffee break, I guess, but before everyone goes to sleep, we continue with the next talk. Ajit is going to take us to high availability, disaster recovery, and fall turns with Postgres story. Let's start.
Thanks. First of all, thank you very much for everyone giving me this opportunity to speak on this topic. I really thanks to FOSSASIA committee on this. So, yeah, so today my talk on high availability, disaster recovery, fault tolerance, and how you can solve that with Postgres solution. I know that many of the speaker before me talk about some of this topic, and I'm going to try to see that how I can differentiate that, or maybe talk on that, right? So my mostly focus on understand the HADR and fault tolerance, right? A lot of the customers or users may simplify or not to simplify in these differentiate. I'm talking that, and how you can solve this with Postgres solution. Bit talk on different kind of solution on that, and maybe final thought about how you can choose one over other, right? So who hell I am, right? So I'm Ajit Garge. I'm field CTO, work with Enterprise DB. I'm based out of Singapore. Been in industry more than 2 decades, and with the Postgres more than 13, 14 years now. So yeah, so I'm speaking many of these conferences, especially this part of world. So let's talk about HADR and fault tolerance system and talk about their characteristics, right? There may be many of the users confused between everything in the same bucket. So bit difference in my opinion. So these are some of the situations where high availability, disaster recovery, and fault tolerance system occurs, right? And especially in the Postgres case, or maybe many of the database user case. Very high level, when you talk about HA, you talk about the single data center or single region, right? You not talk about the cross the region, right? That's a HA kind of system. And then you expect like 99.5 system, RTO, RPO. I'm going to talk about RTO and RPO. Maybe you expect some kind of failover in RTO. You expect zero or not zero, near zero data loss kind of system. And moment you talk about the disaster recovery, you being talk about the cross region, not the single region or cross data center. So how you can avoid these kind of problems, especially when this occurs, when there is a really big outage like flood or earthquake, or unfortunately the data center electricity down or something like that, you expect disaster recovery systems. So how you can build this kind of system using a different Postgres solution. Of course, you expect bit more RTO, which is a recovery time, because the whole region down. So you expect some recovery more time on that. And then you are, of course, you expect some kind of data loss because again, the whole region down. So the different solution based on these two systems. But there are applications which is really do not require downtime, right? And then you come in a fault tolerance kind of system, which is a mix and match of high availability and disaster recovery, right? But then why everybody is not gone FT, right? Then there are some different mechanism to configure that. You of course need a more investment, more server to configure these kind of system, different solutions. So uh, let's talk about CAPS theorem. I'm sure some of you guys know about the CAPS theorem, but then just to repeat, CAPS is C stand for consistency. So either you get the right data which you receive or no data, right? So you make sure that it's a consistent data which is coming to the Postgres server. So not the wrong data you can read and write when you get the read specifically, right? When you talk about availability, right? So every request which you receive, right, it should be available to the user, even in the case of fault tolerance or the fault, or maybe the network partition, right? And the partition tolerance, you have a typically you have a partitioning. When I say partition, the network fail or something is failed, then how you can avoid that? And in that situation, how you can configure the systems. And in my opinion, you can either have one of these. If you have a network partitioning, you either have a consistency or availability. That's a trade-off. You cannot have everything in a single basket when the network partition happened. And this will definitely impact on your performance as well. The moment you try to get the more consistent system, then it will require the sync kind of replication. I'm going to talk on that. But then you impact on your performance. And you need to choose and wisely what your business need, what your system need. Based on that, you can configure that, because Postgres do have a different kind of solution. And based on your need, you can configure this kind of system. Now, this diagram shows you what is the RPO and RTO, recovery point objective and recovery time objective, right? RPO typically measure in terms of data loss. How much data loss you are okay when the system is failed, right? Of course, nobody want a data loss, but then you need to trade off, right? Whether you want a few second data loss, few minute data loss, that's a RPO you need to measure. While RTO is how much time you are okay to not to continue with your business. 5 minutes, 10 minutes. And again, it is not a single time. When I say single time, that means no, typically it's measured in whole year or whole month, right? Based on your availability. So you need to choose what is your RPO and RTO. And again, as I mentioned, its impact on your some of the performance based on you how you configured. But in industry, typically it's measured in a percentage, right? 29, 39, 49, based on the combination of availability. And based on that, you can measure this. Now, how you convert that in the typical standard is, if you are saying that my system is available 99% whole year, that means you expect 3.15 hours downtime, including your maintenance, whether you're doing patching, vacuuming, all these things. And this goes narrow down toward the even the higher system, like up to 5 nines with the 5-minute downtime in the whole year. And then you can measure that into the month as well, depends upon how you can configure. So it's not a single time, it's a whole year, because you may do the maintenance in whole year, patching, upgrade, and all these things. So you need to configure based on your requirement, how you design your RPO, RTO, and different kind of solution. Now, this is all about the understanding of RPO and RTO. Let me check my time as well. I need to see the time as well. This is based on your RTO and RPO. This is understanding of CAPS theorem. This is understanding of the different situations, how you manage the HADR kind of solution. Now let's talk about the solution, what Postgres do have, right? How Postgres can help you to avoid or resolve this kind of system. So very high level, so there are two major things. One is how you replicate the data. That's one portion. And then how you can do automatic failure if in case need to do the automatic failure. I'll talk first about the replication mechanism. The very basic, again, many of my earlier speaker talk about that. But the three things, one is the physical replication in between the two servers, which is we typically call in Postgres streaming replication. And the second is a logical replication, right? These are the two mechanisms in Postgres or process where you can replicate the data. There is a third one, you can share the disk. Instead of replicating data, you share the disk. That required a third-party solution like Red Hat cluster solution. But I'm not going to talk on this today. I'm going to talk on the replication mechanism. Now, streaming replication, some of you guys know about this, is a bit by bit stream to be moved from the WAL files, moved from the one side to the primary side to the standby side. You can configure based on your need again. If you need a RPO, which I mentioned is absolutely 0, then you can configure the sync replica. And in sync, you have multiple methods: sync on, sync off, write apply, write available. Depends upon, again, your RPO ratio, where you system fail. And then you have async replication, which is a by default, where near 0 downtime is required. Then you can get the async replica, but it will give you the better performance compared to sync replica. So this is a very easy method to replicate the in Postgres from primary server to the standby server. You can do the cascading as well if you require. But yeah, this is a very easy method. Most of the users use a streaming replication, even including the availability as well. Now, this is, of course, the primary side. You can do the read and write, while the standby one can use for the read as well if you required. The second method is, before that, there are some limitations. Compare again with the logical replication, with the physical replica, right? Typically, physical replica take a read and write in a single server, not in the other server, in case if comparing with the multi-master kind of solution. But then failover length of the physical replication also take time, because it need to be fail, detect, and apply, right? So take typically 30 to 60 seconds in case if you're using a physical replication. And then everything you're doing on the maintenance job, especially indexing, vacuuming, from primary server, it goes to the standby server. So you expect those kind of things on the standby server as well. And physical replication don't do the filtering of data. If you require to filter the data, you do everything or nothing, right? So those are some of the limitation, I would say, again, compared to the logical replication. I'm going to talk on that. The one more limitation, I would say, that it required same binaries from either primary and the standby. So I just have 5 minutes. Okay. So this is a logical replication. Logical replication, I think one of the speakers talk about in detail. Logical replication on the top of the, if you're comparing with the physical replication, is that you can avoid some of the limitation in logical replication, because you can actually filter some of the data, right, on a logical replication. It's based on a pub-sub model, application subscriber model. I'm not going in detail, I'm just scratching the surface over here. And let's talk about the cluster management solution. The data is replicating. Now, how you can do the auto failover in between this, right? So these are some of the solutions. I'm not saying all, which is typically used by the users. Petroni is one of the great tool which can be used for the failover purpose, auto failover purpose, based on a RAF consensus. I'm going to talk on that. And then Rep Manager is another solution. And EFM is Enterprise Failure Managers from the EDB solution. But these are the really great tool, Petroni Rep Manager. You can use this as well. So one of the architecture using a Petroni is Petroni is based on RAF consensus, required etcd small key value pair, which can you load on the another VM or maybe on the same server, depends on that. But ideally is another VM, and then you require a proxy to land the connection, and you require at least 2 VMs or 2 servers to land a VM for the availability purpose. Bit complex, but then is really good solution, especially on the VM or physical or even the Kubernetes as well. And one of the solution, if you are comparing with that, this is a EDB failure manager, which is on a virtual IP base, bit simple, but it does have its own limitation as well. It doesn't take all of the failure cases, right? And it does have some limitation on auto failback based on JGroup or Java group, this solution. Now, I'll not talk much because I have a limitation, but then one of the thing, the logical replication limitation is it doesn't replicate the DDL. I think it is under consideration, but then improvement in the logical replication you can do with the DDL. It doesn't do the auto failure by default. It requires some kind of proxy, and if the node is failed, it doesn't fail back again. So that's what the distributed Postgres is coming in picture. PGD again is from the EDB. It does data sovereignty across the geo. If you have a across the geo replication required, it does the conflict resolution. It does the conflict detection, and then you can avoid the conflict as well in this. It does have an automatic failure. So very high level. This is kind of architecture you can see in the PGD. You have one region, you have another region. Across the geo, you can do the failure, and within a region, and across the region, you can do the automatic failure as well. So all of this can be possible. One of the solution and it does have a 2 part. One is a BDR, which is a bidirectional replication. And top of that, it does have a proxy, which is a PGD proxy, which can divert your workload in case there is a failure happen. Yeah, so I will skip this slide, but I will talk about one. Now, which one to choose? There are multiple options, right? In my opinion, you should take about the 3 things or 4 things. One is the location preference. Are you really want HA or DR or HA in a single region or across the region? Based on that, you can choose which solution you want, right? What kind of RPO and RTO you require? You absolutely want 0 or near 0 is okay with you, right? You want recovery should be come from the backup server. Again, sorry to talk about backup, but you can do the recovery in backup, or you want recovery from the failure system as well. And then the performance. So performance is really, really important, because the moment you go on a sync, you want RPO 0, you expect impact in the performance. So based on the different solution, you can configure, based on the different requirement, you can configure the different solution using a Postgres different features. I think my time is over. Thank you very much for this. This is my email ID and GitHub. You can follow me on this. I've written some nice PG vector scripts. You can follow me on the GitHub as well. Thank you. Any question?
Okay, we have time for questions. Questions?
Any question? Yeah.
When we talk about multi-master, or binary replication or something else, I see each time the same problem. It's a problem of performance.
Yeah.
You know, on different nodes, you have different data in shared memory, in caches, in buffers. Also, you have vacuum made in different time. So sometimes logical replica works much worse than master. How you strike this problem? How you solve this problem of different performance?
Yeah. So if you're comparing, so in a multi-master, again, if you're comparing the only basically with the logical replication with the physical replication, right? Then I do not have a right now link or slide, but Enterprise DB do have a public, I would say, the performance benchmarking between the physical replication and the logical replication. The moment you start increasing your workload, the number of users, the performance of logical replication, especially I'm talking about the BDR case, right? It almost same or bit higher compared to the physical replication. And we have I do not have right now link, but I can send you the link on that, where you can compare that performance. Now, this is a case of when you configured it the async replication, not the multi-master with the sync replication. By the way, BDR do have a sync replication as well with group commit or with the different kind of latency commit. Depends upon how you want to configure the sync replica as well within a BDR. But if you are comparing with async replica with logical replication or BDR, or async replication with physical replication, the moment you start increasing the number of user, your performance either same or bit higher in logical. I'll send you the link on that. Yeah.
Okay.
Any question?
Any other questions?